Right. Hello, my name is Mike Zellers. I'm the teacher for CISS226, Introduction to Java. And I want to talk a little bit about the way this course is structured before we move on to the course material. I do not read the syllabus to the class. You can read it on your own, and you should read it on your own so you know what you're up against. Thing about this class is set up in what is called, it's set up, it's a hybrid class, a blended class, and it's set up in what's called high flex, which is a word I didn't even know until a couple months ago, even though I was doing this for a few semesters. High flex means simply highly flexible. So what I've aimed to do is to accommodate any of your needs and your responsibilities by offering this class in a number of different ways. Class will have a in-person lecture, all right? So one a week, the rest of the materials is online. On Mondays rather. Well, I don't know what day of the week it is. You can tell it's the beginning of the semester. Mondays from 1 to 2 in this room, BU 103. If you want to attend the lecture in person, you are welcome to do that. And that doesn't just go for the people that are in this room, that goes for anyone else that views this video or that, you know, views the WebEx broadcast of this. So one way that you can view the lectures is to show up in person. A second way you can do it is synchronously, that is simultaneously at the same time. You can connect to my WebEx room between 1 and 2 on Mondays. And you'll be able to view the class via WebEx. So this class is going out in my WebEx room and you can view the class that way. And the third option that you have is you can watch the recording of the class, which is usually posted within an hour or so of the end of the class. So this is meant to cover any situation that you run into. You know, if you change shifts on your job and you can't attend in person anymore, you can watch the recordings. If you have a sick kid and you have to stay home with them, you can watch it synchronously via WebEx without leaving your home. If the weather is bad, you don't feel like driving, going out in it, you can watch it from home. This isn't like a choice that you make for the entire semester. You can choose every individual week, all right, what you choose to do. There's advantages and disadvantages to both. Some people respond better in a face-to-face, in-person way, and you have that option. Other people may not be able to get physically on campus, but they want to be viewing the class synchronously. That is, in line, you know, simultaneously as I'm doing it. And the advantage of that is you can interact more with me and the rest of the class by hearing class discussions or answering questions that will get answered immediately. Watching it after the fact, after the video is posted, the chief advantage of that is you can do that anytime. If you just can't be here during the scheduled hours to either watch in person or on WebEx, you can always watch the video, and the convenience is sometimes if you're having difficulty, it might be a good idea to come in. Now, the labs work in a similar way, all right? But there's a couple of twists with the way I run my labs and compared to maybe some of the other CISS profs. The scheduled lab for this class is immediately following the lecture from 2 to 3 or 2 to 2:50 in BU 210. All right. Same rules apply for that. You can watch. You can show up in person, or you can dial in via WebEx and discuss any issues that you have with me during that time. So that's how they work. Coming in through WebEx has a nice feature that you can actually share your screen with me. So I can actually see what you're working on and help you identify what could be going wrong and what the issue might be and so on. So it's really, really cool. Now, for those of you that can't be in lab, either in person or on WebEx, you can schedule other sessions. I try to make my schedule very flexible. When you have an issue, please email me. And if you want to talk to me in person, give me a list of times that you're available. You know, I'm available Tuesday afternoon, Wednesday evening, and Thursday morning. Example. That would be you saying that your availability. And then what I will do is I'm usually able to find sometime within the time ranges that you give that I'm available as well, and then we can set up an appointment for that time. Obviously, the more notice you give me, the better. Like if you were to contact me today and say, I want to meet online at 4 p.m., I might not see that message until tomorrow. So you might, it might be better, if you say, I want to meet you tomorrow at 4 p.m. That way I have a chance to read the email. If you do send in a question concerning a project that you're working on, I asked you to remember these things. Zip up and send all your files and attach it to the email message. So if you're having problems with something, send me all the files related to the project. The best thing to do is have all those files in a single folder and zip up that folder. Give me a complete and specific description of your issue. So don't just say this program doesn't work or this program gives me inaccurate results. Tell me what is inaccurate about it. Don't make me have to go and hunt and search through to try to find what the problem is. Identify the problem as specifically as possible. Include screen captures if you think that would be beneficial. All right. I ask you not to upload assignments to the Dropbox until it's ready to be graded. So if you have a problem with something, do not upload it to the Dropbox and say, I have a problem with the assignment. All right. I will only see that when I go to grade, which is about once a week. If you email me, I'll see that within the next day. All right. And so I check my email much more frequently than I go through and grade stuff. So for a quicker answer, follow these rules, email me the questions you have, be complete and descriptive about the problem that you're running into, send all the files, and maybe send screenshots if you think that would be effective. If you do those things, you're more likely to get better assistance. Sometimes, we go around for email, do a couple rounds of emails where you ask a question, I give an answer, and we go back and forth. I might suggest that we schedule an online meeting if it just gets to be where we're playing email tag or whatever. So keep that in mind as well. But my aim is to be as flexible as possible, both in the way I deliver lectures and the way I deliver labs. So I mentioned before, there's only one lecture per week. And that is on Monday. There is no school. School is closed next Monday for Labor Day. Therefore, there will not be an in-person lecture. I will instead publish a lecture from another semester, from previous semester, that you can watch. Especially the first couple of classes are pretty consistent what I cover in them. So you won't be losing any of that content. Does anyone have any questions about that now? How this class is run? Yes.
I'm guessing there's no points against you if you don't show up, whether
Correct.
to it live or you just listen to it.
There's no grading benefit to showing up live or or watching it synchronously or watching it asynchronously. So I'm interested in you getting getting the material and doing a good job. You show that you've done that work by doing a good job on your assignments. So that's what I'm concerned about, is that you do a good job on your assignments. there'd be almost no way for me to tell that you watched the YouTube video.
That's what I was thinking.
Right. Yeah. So, I would, I wouldn't give any points associated with that. Any other questions? Okay, let's jump into materials and start to have some fun. Let's look at, first of all, a little bit of how the course is structured in Canvas before we actually get in the material. So I was a little premature. Read all this information first, all right? This talks about the blended class. It has a link to my WebEx page, and it has this info about setting up Java. What you will probably do, if you do not already, is you'll probably want to install Java on your machine. And we'll spend a minute talking about it. We might even, I don't know if I have permission to do it, but I might start to run an install just to show you what it's like. And, but you probably want to do that very quickly. Yes.
When you say install Java, are we going to be working with how do I say this? So will we be using Visual Studio Code, or will we be using something that Java will provide?
I would encourage you to use Visual Studio Code.
I wasn't sure if it was like Python.
Yeah, no, I would encourage you to use Visual Studio Code. Later on in the semester, we will use a more involved IDE, but starting off, I just like to keep it real basic and simple. So you're really focusing on the nuts and bolts of the language, and you're not relying on the IDE to do the work for you. Okay. Right? So let's see what this link takes you. Okay, wow, we have a lot of downloads possible. You want the JDK. If you do a search and you see something about the JRE, that is, you'll get that along with the JDK. The JRE just allows you to run Java code. It doesn't allow you to develop and compile Java code. So let's see. Download one of these.
Which one?
Doesn't really matter which one. It's not worried about it, or this is set up with an administrator account. Okay, Java's installed. Now, there's a second thing that you need to do besides running it through the installer. It's like, wow, that's awful easy. It was easier than I thought. And it's mentioned here, setting up the computer to do the assignments. Oh, it points to a page in the textbook. That's right. I'll tell you though, the thing that you need to do, is set the path of the of Java. The path is where it looks for stuff, the commands, the libraries, and so on. Let me go to the command line, and we'll run these codes, at least initially, from the command line. You just type in path, you'll see this. Right. If you look under path, you need to put in something like this. Here's for an earlier version. You need the bin or something like this. You need to adjust the path within Windows. This is assuming that you're running Windows. You need to adjust the path so that you're able to access and run Java code. How do you do that? Well, that's a good question. I think I remember. Go set path. Don't remember what I'm saying, set path or set environment variables. All right. And it talks about it here. Go to system information. Ah. Control panel. Go. And under
I have a question. I was supposed to have a class right next door, but there's nobody in there. It's not the class.
are you looking for the Java class? Okay. What class are you looking for?
The hospitality law.
Okay. I'll tell you what, I don't know anything about that. I would double check to make sure that it meets Monday and not maybe it meets Tuesday and Thursday. The other thing you could do is go upstairs to BU 211J or BU 211 rather. And there should be, administrative assistants in there that could probably answer your question better than I can. No problem. Okay, administrative tools. Boy, I am not doing well finding this.
I did it once with Python. I don't know how to get back.
Yeah, me either. Let's see. Windows 10 and 8. Control panel. The advanced. I do most of my work on a Mac, so I system properties, click the start button and type in environmental properties, okay? There we go. Environment variables. And if you look down here, you'll see path. And you'll see at the very beginning of it is this. If the installation process didn't already do that for you, do it yourself. You know, go in and know where it is and edit it. But I guarantee if you do this and you get an error, if you go to the command line and go to compile something, and you get an error saying it can't find the command, here we got a help because we didn't put in a file name to compile. If you get an error saying it can't find it, then the problem is that your path variable isn't set up correctly. That is often the problem with people with installation. All right. So you probably want to do that as soon as possible. That way you can work on your machine on the assignments. You are given lab time. I mean, the lab is essentially time for you to work on your assignments, but again, many assignments might take longer than the lab time to complete. All right. As you know, in many programming languages, the first thing that you learn to do is to write a Hello World application. So we're going to do that. And we're going to do that just as a way to sort of start to understand how Java applications are pieced together, what elements they have. So let's look at this page, Hello World Explained. And I'm going to create this file and we're going to copy it. And I'll let you read this explanation. I'll give my own explanation now. So I'm going to go into Visual Studio Code. Paste that code in. Okay. And then I am going to save it as a Java file. I'm going to save it as a Java file. And I will just put it on the desktop. Now, when we save a file, we're going to save it using the class name. We'll talk about classes in more detail later, but because this class is named Hello World App, we need to save it as Hello World App with the same capitalizations as in the class name. There are conventions for this, and you ought to follow them. And the convention for class names is that the first letter of each word is capitalized. So Hello World App, with the H, the W, and the A capitalized. We'll go and we'll save it on the desktop. All right. That gives us the source code. Here's how Java works. I'm going to show my artistic skills in Paint. It's just been a while since anyone used Paint, right? Oops. The source code is in a .java file. When I say source code, I mean that's the code that you will write. You will edit, you will write, you will come up with the code. It's where the Java code lives. All right, it's meant to be human readable. By human readable, I mean someone that knows Java readable. All right. That actually, when you compile it, you produce a .class file. All right. And the Java.class file is what the Java virtual machine runs to execute the program. This is called bytecode, by the way. And it's not human readable. It's readable by the Java virtual machine. This allows Java to make the promise that you write once run anywhere or run many times, this process, because as long as you have a Java virtual machine installed, as long as you have the correct version of a Java virtual machine installed, you can take code that was compiled on a Linux machine, for example, and run it on a Windows machine, or compiled on a Windows machine and run it on a Mac, or any kind of combinations. That as long as there is a Java virtual machine written for that particular hardware, which there is all the common, not hardware, but operating systems. So the process of compiling takes the Java file, compiles it in the class file, and the class file actually gets run. So let me go, I've saved it, let me go compile it. Why do I keep closing my command line? Okay, I'm going to get to the desktop. This requires a little bit of remembering. I hope you've had CISS226 where you do command line stuff. If not, I could give a quick refresher on that. CD is to change directories. So this comes to your user directory. To get to the desktop, you do CD desktop, and there you are. If you want a directory listing, you can type in dir. That will show you a list of all the files. And where is it? There it is. So we're in the right place. Starting off, we're going to be in the whatever folder our Java code is we need to get to. We need to navigate to. And you do that with the CD command. Later on, we'll talk about putting things in different directories, but for now, all our classes are going to be in a single directory. To compile, you type in javac and the name of the source file. No news is good news. You don't get anything like that, it means it compiled successfully. And then you can run it. You run a Java program by typing in Java and the name of the class. And it goes and does its thing and types in hello world. We'll notice now that we have both the hello world app.java and the hello world.class. So when I type in Java hello world app, it's actually running class file. Any editing I do will be to this file. And if I make a change to the source file, I have to recompile it to reflect that. Now, sometimes you're not so lucky and get it to compile the first time. Let's go in and intentionally make an error. Let's go and intentionally make an error. Like I'll forget one of those curly brackets. If I save it and then compile it, nice trick to do while compiling is if you hit the up arrow, it takes you backwards through the list of commands that you've run. So that takes me to that. One more time takes me to that. One more time takes me to that. And I compile it. Now, you'd think it would give you a nice error, like you forgot to put an ending bracket at the end. It didn't. It gives it to you in very, what would you say, very literal, very mechanical way. And what this says is it's reached the end of the file while parsing. And it shows you the end of the file. What does that mean? Well, what the error message doesn't say is it reached the end of the file and it was still looking for something. All right. So it got to the end of the file and it didn't find something that it needed to find. And in this case, it needed to find the second curly bracket. It didn't, therefore it reached the end of the file without finding that, and therefore that's what the error means. My whole point of going this over is sometimes the error messages are cryptic. All right. Let's get rid of the N here. So let me save it. Error can't find symbol. Method print L string. That's not as straightforward as, hey, you forgot the N. All right. It takes a little while to sort of get these Java error messages. And if you get one and you have any problem with me, just let me know and I can help you translate it. At the very least, it gives you a pointer of where the error is around. Now, notice I said where the error is around, not necessarily where the error is, because sometimes Java can't detect an error till it gets a little bit further down the line. Put the N in here. All right, let's get back to where it runs. And it's back to working. Okay, that's the mechanics of saving and of compiling and running a Java program. Now let's look at the class itself. All your code in Java is going to be in a class. All right, it's going to be a class. Now your application will have at least one, call it the boss class. All right. The boss class is the class that you can actually execute. Because you can't execute, I can't type in, if I had a bunch of classes in here, I couldn't type in Java C and just the name of any class. If I create a customer class, I couldn't necessarily type in Java C customer, Java C student, whatever. All right. The only classes that you can run are classes that contain this main method. Method, function, means the same. If you've done C# programming, you should recognize that the curly brackets are used to like group things together. These are comments. If you have multi-line comments, you can do a /* and then a //. You can put the comments anywhere at the beginning of the line or at the end of the line. You declare your class, lowercase c, your class name. It should follow the convention of capital of each initial. First letter of each word should be capitalized. I then have braces that go around the entire contents of the class. Now, classes contain what? Classes contain two things. All right. This might be review, this might be new. We're not going to really go deep into this, but I just want to sort of introduce this and we'll talk about it in next week's lecture. Classes have attributes and methods, or variables and functions and so on. This one doesn't have any attributes. All right. So in fact, it only has a single method and it has a main method. Here's how you declare the method. First, start out with public. Could be public, private, or protected. For the most part, your methods are going to be public. This one would have to be public in order to run the application. If it wasn't public, then you couldn't even run the application. Question?
Difference between the public, private, security.
Pardon me?
What's the difference in the public, private, and security?
Protected is the third one.
Okay, what do they do different?
Public means any class can access that method. Private means this method can only be accessed within its own class. And protected means that it can only be executed by this class and anything that inherits from this class. So we'll study inheritance. We'll go over this in more detail now, but I did want to introduce you to the idea of public. So this one has to be public. You don't have any choice, right? Static. I'm going to give you a brief explanation of this, and if you don't get it right now, don't worry about it. Just type in static, all right? Static means that you don't require an instance of the class to run the method, all right? There are sort of class level functions and there are object level functions. This makes it a class level function, which means that you don't have to create a new instance of this class to run it. Void means that this method returns nothing. Main is the name of the function. And by the convention, the first letter of the first word is lowercase. Each subsequent word is capitalized. It's sometimes called camel case. I don't know where they get that from, like the head of the camel is down and the humps are the next words. I don't know. That's what they call it. And I do want you to follow these conventions. And if you don't, I probably will mention it. And I might at a certain point in the semester actually deduct for it. Because it's one of those things that, like, you know, yeah, you're allowed to do it, but you probably shouldn't. Enclosed in the parentheses are the arguments. Now, arguments are different things that you could send to this method, or you could then access them within the method. Let's just do this for laughs. I think I'll be able to do this. I can pass on the command line. A parameter that you can use within it. We're not going to use that real often, but I did want to explain to you what that args is. That's arguments that you can optionally pass to this program to get it started. I'm just off the top of my head thinking that one cool thing that you could do is you could have a test mode and a production mode for a class. And if you passed it test, it would behave a little bit differently than if it was in production. That's one way that maybe you could do it. But again, we're not really going to do that much often. I just want to explain that to you because I want to go over the entire thing. All right. We then have our function, which is again delineated by the braces. Everything within this function is within these braces. Get rid of this guy. Now that we've seen what it does. I got rid of one of the braces too. All right. This is how you output something. When you run a Java application, it has sort of a system input and system output. And by default, which is probably the way that you want it, the default output is outputting to your computer, outputting to your computer screen. So this says take the system variable, take the output on that system variable, send to the output a printout of this string. Println will print each thing on its own line. That's why when we typed in, when we had the one that said goodbye, it said hello, goodbye on subsequent lines. So to output anything, we're going to do something like this. This part's always going to look the same. What's within the parentheses, of course, is going to be whatever you need it to be, whatever you need to output. System is capitalized. What do you think that tells us about system? What other things did we say are capitalized? Class name. So system is a class. All right. That means that these things are probably static functions, right? Because they're running on a class. If you're not sure on that, that's okay for now. But I just wanted to point that out. Any questions about this basic class? By all means, read through the explanation on that web page, because they might point out things I missed, or maybe explain it in a different way that might be useful for you. I do want to take this to the next level. All right. And I'm actually going to do that by downloading a slightly different version of the HelloWorld app, an enhanced version. Let's download it. Download it to the desktop. Do you ever see me do something like type in ls instead of dirs because I'm thinking in Mac/Unix? Okay, my new Java class is called HelloWorld 1. Now I'm going to try to compile that. I'm telling you in advance I'm going to get an error. That way you don't say, oh, he screwed up on the first day of class, all right? Because I know I'm going to screw up. I go to compile this, and alas, I get an error. I get an error because the class name does not match the Java file name. For some reason, when I upload this to Canvas, I think I had 2 Hello World files, and it named this one -1. So the file is called Hello World -1. And yet, if we look at the class inside of it, the class is, I want that one. I don't know what's wrong. I'll open up in, there we go. Swear, you saw it. I was right mousing on that one and clicking. I don't know. I'm getting to that point where I make, sometimes a mistake here and there, but not like that. Okay, the problem was is it's called Hello World and the file is named Hello World-1. So I can fix that by going into here and renaming this. Just Hello World. And now I can compile it. Now I change the name to Hello World. I can run it. And what this does is this displays hello, and it picks a name from a list of names. All right, randomly. Because you're going to need random numbers for your first. You're going to need an array and random numbers for your first assignment. So this allows me to do that. So let's look at this. The rest of it is the same. I gave the class a slightly different name. This is one way that I can declare a string array, an array of strings. And I imagine you know arrays from C# class, same idea here. Instead of a single value, there's a list of values. So this is how I can declare an array and initialize the array. Now, one thing about arrays is you can't change the size after you have declared them. So this is now set at having 4 elements. All right. This is set at having 4 elements. So I have an array called names. It consists of strings, and I've initialized it to an array of 4 elements. I then declare a variable, an integer variable called random, which takes math.random, multiplies it by 4. Oh, there's a bunny outside. Math.random gives me a number from 0 to 0.99999 repeating. All right. So if I take that number and multiply it by 4, my answer is going to be between 0 and 3.99999 repeating. If I make that an integer, then I get a number between 0 and 3. So that allows me to generate a different. There's a better way to do this, by the way. And if you do your homework assignment, try to figure out the better way to do this instead of saying multiply by 4. All right? Yes.
And you said you couldn't add another. This is a question mark. Could you add another name to that the array there? Let's say you want to add, for example, everybody class extra 3 names.
I could not add it to that array.
How would you then update the array of exchange?
There's a few ways you could do it, but if it's something that's dynamic, you would probably use what's called an array list instead. An array list is like an array, except it can expand and contract, and you can add stuff and delete stuff, and it's much more flexible than just an array. I didn't want to jump into using array lists initially because they're sort of a new concept, and some of you, most of you have probably seen arrays before, so it's like, okay, let's just work with those, and then we'll get to array lists pretty soon. So I then say, give me the name element represented by that subscript which again is going to be 0 through 4, to either give me one of these 4 numbers. Now, your assignment is to create a Mad Lib where you have maybe 3 blank words in your Mad Lib and you randomly choose from a list. Try to write a better statement than I did for this one. All right, there's something you can do that's actually a little bit better than this. Not to say it doesn't work, but you can do it better. That's something that is important to recognize, that just because a program works doesn't mean that it's the best it can be, right? And you know, your first goal obviously is to get it to work, but then you can look at things to make it even better. And usually by better, we mean more maintainable. In other words, if I make a change to this, I don't break this. Now I could add a name this way by just adding it on the list, and the next time it run, that array would have those names, by the way. But I couldn't dynamically add names like throughout the program. All right, yeah, I realized that maybe I was a little misleading there, so I came back to that. Okay, that's all I had today. Are there any questions? All right, remember, there is no lecture next Monday. You will get a lecture from last semester and or previous semester. And I'm going to go upstairs to 210 where lab is, and you're welcome to come up there if you want to work on the lab, or you can work on it on your machine on your own time. It's really up to you. All right, take care.